Oh, this is different. Now you have a quantity involving an unknown, in this case y. Same direction, solve for y in part C. We have the quantity 3y plus 7 squared. That whole quantity squared equals 1. Do you think solving by taking roots will work here? Well, okay, let's just try it and see. So let me rewrite the equation. We have 3y plus 7, quantity squared equals 1. And it would be, so the 3y plus 7 is stuck inside those parentheses, right? Because you're squaring that quantity. One way to get rid of the parentheses in this case would be to get rid of that exponent of 2. So let's try taking the square root of both sides and see if something good happens. So if you take the square root of both sides, what do you need to remember in front of the square root of 1? Plus or minus. And then what would the square root of 3y plus 7 quantity squared equal? Would it get rid of the exponent of 2? It would. And you'd be left with just the quantity 3y plus 7, but no need for parentheses now. Because the only reason for those parentheses existing, they told you to square the entire quantity 3y plus 7, but now that exponent of 2 is gone. You don't need those parentheses anymore. So you get 3y plus 7 equals plus or minus root 1, but what is root 1? Just 1. So plus, don't keep the radical around. Get rid of it. Square root of 1 is 1. So you have 3y plus 7 is equal to plus or minus 1. Oh, that's really two equations, right? I think you better write them down separately now. 3y plus 7 is equal to negative 1. The plus or minus means 3y plus 7 could equal negative 1, or it could equal positive 1. Do we know how to solve those kinds of equations? In fact, they're linear equations. We know how to solve every linear equation there is. So taking roots worked well in this one. Let's finish it up. Solve the first equation. 3y plus 7 equals negative 1. What do? Subtract 7 from both sides. What does that get you? If you subtract 7 from the right side? Negative 1 minus 7. Negative 8. So what does y equal? Divide both sides by 3. You get negative 8/3. Okay, the other equation, you subtract 7 from both sides again, but this time it's 1 minus 7 on the right side. So what does that get you? Negative 6. Divide both sides by 3 again, but what does that get you this time? Negative 2. Do you think you could check both answers here? You can always check your answers, guys. You can plug it back into the original equation. Let's just try one of them. Let's try the negative 2. Do we get a true statement? What's 3 times negative 2? Negative 6 plus 1? 1. Squared is 1. Yeah, it's going to check. Same with the 8/3. That should check too. Negative 8/3. In part D, same direction, solve for x, solve by taking roots, the direction said. Now your first temptation might be to actually set it equal to what? 0. And if you did that, you get x squared minus 12x. Okay, add 8 to both sides. What's 36 plus 8? Plus 44 equals 0. Then you'd have to come up with, when you factor it, if it factors, you'd have to come up with two numbers whose product is what? 44. To get these last numbers here and here, you'd have to come up with two numbers whose product is 44 and whose sum is negative 12. Well, how does 44 break down? 4 times 11? Is there any way to combine 4 and 11 if you make them both? Well, they'd have to both be negative, right? Because you have a plus on the end and then a minus in the middle. Is there any way to combine a minus 4 and minus 11 to make a negative 12? No. There's other possible factors, right? Minus 2 and 22, but no, that's not going to work either. I don't think this thing factors. So we're out of luck. It doesn't factor. So that method of solving by factoring doesn't work. So what do? Well, I noticed something about the trinomial on the left side. X squared minus 12x plus 36 factors to be something special. So what is x squared minus 12x plus 36 factor to be? Yeah, x minus 6 quantity squared. Now, this is a very special situation. Normally, that trinomial wouldn't be, I mean, you could think of adding any other number than 36, and it wouldn't be a perfect square trinomial, would it? But it is a perfect square trinomial, so we can use the same method we used in the last example to solve it. What could we do to both sides here? To get rid of this exponent of 2, take that square root, right? What do you need to remember in front of the square root on the right side? Plus or minus. Okay, then what's the square root of x minus 6 quantity squared? Just x minus 6. And we just did a little bit ago the square root of negative 8. What does that break down to be? 2i rad 2. So we don't need to go through that again. But basically, you poke the I out, right? And then you simplify the square root of 8 as usual, which is 2 rad 2. So you get 2i rad 2. And then if you want to get x by itself, what could you do? You could, by the way, in the last example, we split it up. We made it 2 equations based on the plus or minus, right? In this equation, there's no reason to do that because there's no way when you add 6 to either equation that you're not going to be able to combine the 6 with the 2i rad 2, right? They're not like terms. So you might as well just do it all in one here and isolate the x all at once, add the 6 to both sides, and then that gets you just the x by itself. And then the best way you can write the answer on the right side is to go 6 plus or minus 2i rad 2. And just keep in mind, that's two different answers right there, right? 6 minus 2i rad 2 and 6 plus 2i rad 2. Two different complex solutions. Does that make sense to you? Do you think you could check your answer here? Or answers? You could. It would be more complicated because you're squaring stuff involving I, but you could do it. And if you do it right, you should get negative 8 on the right side. But I'm not going to take the time to do it right now. By the way, your calculator, if you have like a TI-84, your calculator will accept numbers with I in them. You just hit the second function of the decimal point. So you can, I'll show you that at some point. You can play with it.